chapter, which is motion in one dimension. This topic we discuss about motion of objects. Arif, what do you understand by rest? When do we say a body is in rest? Manu, will you like to explain? When you say a body is at rest?
Yes, sir. So when the body is moving and there's no change in its physical movement,
So it's not moving, it is said to be in rest.
it's yeah.
Okay. Body is said to be at rest if its position with respect to its surrounding does not change. So right now, mostly with respect to anyone around me, I'm not changing my position, so I'm at rest. Similarly, a body is said to be in motion if the position changes with respect to the surrounding. Okay, for example, a car here. If this is moving with some speed, its position is changing. Okay, at every instance of time or at a different instance of time, it is at different positions. So we can say this car is in motion. Okay, this year, when we talk about motion, mostly we are going to talk about one dimensional motion. Okay, so in the later part of the chapter, the equations which we learn and the problems which we solve are mostly with respect to one dimensional motion, where a body moves along a straight path. So this car goes forward or backward, something like that. Even if the car is traveling from place A to place B along a curved road, we'll assume that the road is almost straight. So in certain problems, they will say a body is going from Bangalore to Mumbai. So we will assume that the body is going in almost a straight road. Clear? When the body is moving in a straight path, such motions are called as rectilinear motions. Okay, let's move further. Distance. Distance is defined as the total length of the path traveled by a body during any journey. So if suppose a body starts from a point A and it moves to point B along this curved path, okay, where the length of this path is 5 kilometer. So in this case, the actual distance traveled by body A or the body is 5 kilometers. That's the distance traveled by body. Okay, the second point says here, the path may or may not be straight. So it can be a straight path or it may not be a straight path. So we just calculate the actual length of the path which is traveled by the body. Distance is a scalar quantity. What do you mean by scalar? Can anyone explain me what is scalar quantity? It is the
magnitude on which it's represented.
It is the magnitude. Okay, you're somewhat what correct. Yes, Aswi?
So scalar is like the task, like it possesses it has magnitude or size. It represents.
It has a magnitude. Okay. And what it does not have.
So it does not have the direction. It does not show the direction.
Okay, very good. So scalar quantities are quantities which have magnitude but have no direction. Okay, so here as you see, this body, when it is traveling from point A to point B, at different instances during the journey, like maybe at this point, it's going towards this direction. While at this point, the body is going in this direction. Okay, at this point, it's going in this direction. So this overall journey, like in this overall journey, at different point, okay, the object have different directions. So there is no fixed direction. Hence, distance overall has no fixed direction. It's a scalar quantity. So scalar basically means a quantity with no direction and only magnitude. Magnitude means a value. Okay, it is represented by a symbol S now, not D. We have used D for distance a lot of time, but this chapter we will be using mostly S for distance. Correct? SI unit for distance is meter, though distance can be calculated in other units like kilometer, decimeter, centimeter, millimeter, gigameter. Okay, so there are many other units of distance, but the SI unit here is meter. Okay, okay. Let's discuss another physical quantity, displacement. Displacement is the shortest distance from the initial to the final point of the body. So if a body is traveling from point A to point B, okay, where distance represents the actual path traveled by the body, or distance means the actual path traveled by the body, displacement only means the shortest distance from the starting point to the ending point. Okay, so like the previous example, if suppose the original path is 5 kilometers, but the shortest distance from A to B is just 3 kilometers. So even though body is traveling 5 kilometers, displacement of object is only 3 kilometers. So it is only the shortest distance from the starting to the ending point. Displacement is a vector quantity because it has a direction. So this overall displacement have a direction, like it's towards the arrow, or the like an arrow, like you can say the ray, which is directed from A to B. So this is the direction of displacement. Again, SI unit for displacement, like distance, is meter. Differentiate between distance and displacement. So here is a table which gives you differences between distance and displacement. Distance is the length of the path traveled by the object in certain time. So it's actual length of the path, what actual path it travels. While displacement is the shortest distance from the initial to the final point. Distance is a scalar quantity, means it has no direction, while displacement is a vector quantity, means it has a direction. Again, distance depends on the path followed by the object. So if you're traveling from point A to point B, you can take multiple paths. They can be in like different ways of reaching from A to B. Like this can be one path. Another option could be like this. Another road goes like this. Maybe a third path goes like this. Okay, so all these paths, let's say A, B, and C, have different length, and hence if you travel from A to B along these different routes, you will end up traveling different distances. But in all these cases, the final displacement remains the same. So because displacement only depends on initial and final position. So irrespective of which path you choose, your displacement remains the same. Am I clear?
Yes, sir.
Yes.
Can distance ever be more than displacement? Is it possible that distance of the object travel is more than the displacement during a journey? What do you think? Anyone can say. Distance.
No, sir.
No. Right. Can distance be equal to displacement?
Yeah, it can be.
It can be equal. It can be equal if suppose the body travels along the straight path. If it goes from A to B directly, okay, along the straight path. In this case, or in this situation, distance and displacement are same. But if object chooses to go through along any other path, not same as the displacement path, then in that situation, distance would always be greater than displacement. So either the displacement is equal to distance or it is less than distance. It can never be more than distance. Clear? So that's what is given in the last point. Distance can be more or equal to the magnitude of the displacement. Displacement is either less or equal to the magnitude of the displacement. Equal to the magnitude of the distance. Clear? Okay. Let's go ahead. Speed is defined as the distance traveled by an object per unit time, or the rate of change of distance with respect to time. Therefore, formula for speed is distance divided by time. Okay. So it's just distance divided by time gives you speed. SI unit for speed is meter per second. Like since speed we also write both speed and velocity, which we will study later, is represented mostly with symbol v now in this chapter. Okay, so v is defined as distance s divided by time. SI unit for distance is meter, and SI unit for time is second. Therefore, SI unit for velocity is meter per second. Correct? Like distance is a scalar quantity and it does not have a direction. Even speed is a scalar quantity, it does not have a direction, it just has a magnitude. Okay. SI unit is meter per second. We write it like this, meter per second, or we can also write it like meter per second. Correct? And this is a scalar quantity. Okay. The next definition is velocity of body is defined as the distance traveled by an object per unit time in a given direction. So velocity is similar to speed, but here the distance is traveled along a particular direction. Or we can also say that velocity is equals to displacement divided by time. Okay, so total velocity or average velocity is displacement by time and not distance by time. That's the only difference. Again here, since velocity is equals to displacement by time and unit for displacement is meter, unit for time is second. So unit for velocity is meter per second or meter per second, right? Because displacement is a vector quantity and it has direction, even velocity is a vector quantity. Clear? Speed is defined as distance traveled by a moving object per unit time, while velocity is defined as the distance traveled by a moving object per unit time in a particular direction. Or we can also say it is velocity is nothing but displacement time traveled by body per unit time. So it's displacement by time. Speed is a scalar quantity, while velocity is a vector quantity. It is always positive. It may be positive or negative depending on the direction of motion. If a body is moving in a circle, then after one round, the average speed is not zero. If a body is moving in a circle, then after one round, average velocity is zero. The first few problems are very easy, so I will just keep it open to you. Let's see who can answer. Motion of a train on a straight track is an example of dash motion.
So one dimension.
One dimensional motion. Very good. See, one dimension means where body is just moving in one single direction. Okay, in a straight line like this. That's a single direction. So train mostly go in a straight line. Mostly, like we almost approximate it to be a straight line journey. Okay. Because and it's even given in the question that it's a straight track. It's not a curved track. Suppose a body moves on a curved path like this. So in this case, it's going left and right, like it's going towards the right direction. Plus, it's going above. So it's a two-dimensional motion. Am I clear?
Yes.
What is SI unit for displacement? Meter. Good. Next question. A body starts its motion from point A to B
Zero. Displacement is zero.
and comes back to the same point after a certain interval of time. So what's the displacement here?
Zero.
Zero. Zero. Good. Parishi, can you hear me?
Yes, sir.
Can you try explaining me this question? A body is traveling 10 meters per second for 10 seconds. In 10 seconds, how much distance it will end up traveling?
100.
100. How did you do that?
So basically, I multiplied both of them.
You multiplied both of them. Yeah. So even the formulas suggest us to do the same. Speed is equals to distance by time. Please don't get confused with the symbols. This is what we use this year. S for distance, T for time, and speed with V. Therefore, distance traveled is equal to speed multiplied with time. Speed is 10 meter per second divided by multiplied with time 10 seconds. Okay, so 10 into 10, 100 meters. SI unit for velocity is, yes, Manav.
V.
Manav is
Plus
Manav or
V.
Manas?
Plus one of the last answer option.
Option D. The SI unit for velocity is meters per second. A car is moving at a speed of 72 kilometer per hour. So can you find speed of car in meters per second? In kilometer per hour, it's 72 kilometer. There were questions like this.
So
So how to convert speed in kilometer per hour to meter per second?
you multiply by 18 by 5
Are you sure?
or 5 by 18?
5 by 18.
It is 5 by 18. So speed in meter per second is 72 multiplied with 5 by 18. So 5 by 18 meters per second. Okay, 18 goes with 72 four times. Therefore, 20 meters per second. That's our final answer. I would also like to explain you why we did 5 by 18 or 18 by 5 so that you can generalize this understanding. So let me quickly tell you how we got this. See, 1 kilometer per hour means I can write it like this, 1 kilometer per hour. Now we need to convert this kilometer per hour to meter per second. Okay, I can always say 1 kilometer is 1000 meter, correct? And 1 hour is nothing but 3600 seconds. Is that right? 1 hour is
Yes.
60 minutes and 60 minutes into 60 seconds. So that is 3600 seconds. We can cancel the zeros over here. Okay, 10 and 36 goes like with 2, it goes 5 times and 18 times. So that's how we get this answer. Like 1 kilometer per hour is 5 by 18 meters per second. Understood? I hope that's fine.
Yes, sir.
Yes, sir.
So we just convert kilometer to meter and hours to second, and that's how we get that number 5 by 18, and we just need to remember it. Okay, moving to the next question. This time we need to convert from meter per second to kilometer per hour. Express 15 meter per second to in kilometer per hour.
15 into 18 by 5.
So here we do 18 by 5, the reverse. Okay, 5 goes with 15 three times. Okay, and 18 threes are.
54.
Express each of the following in meters per second. It's 1 kilometer per hour. Okay, this we need to convert to meters per second. So here I can directly say it is 5 by 18 meters per second. Okay, that was easy because we have already done the calculation and we know the value. But how do we convert from kilometer per minute to meters per second? So as I told you, in like conceptually 18 kilometer per minute. Manav is raising his hand. Okay, Manav, try. Tell.
So can you convert the minute to hour and then use the formula?
Or why don't we simply convert minutes to second and kilometers to meter?
Oh, that will work too.
Yeah, why do you take the longer route? Okay. So kilometer, just convert this to meter. So 1000 meter and minutes to seconds. So 60 seconds. That's all. 18 goes with 60. Okay, directly doesn't cancel, but I think with 6 it goes 3 times and this goes 10 times. Okay, and 0 cancels. So this is 300 meters per second. You have 3 speeds given here, and we need to arrange them in the increasing order, like from smaller, lesser to greater. And the speeds are 10 meter per second, 1 kilometer per minute, and 18 kilometer per hour. Okay, we need to compare and arrange them in increasing order. Just a hint is like if you want to compare the 3 quantities, right, convert them all to the same unit. That's it. So my advice would be to convert all of them to SI unit, like this to meter per second, and this also to meter per second. Then only you can do the comparison. At this point, you can't do the comparison. It's not possible.
It remains like 10 meter per second.
Okay, very good.
And then the second one, you have to convert it into meter per second. So you do that 1 into 1000 by 60.
Okay, good.
And I got 50 by 3 meter per second.
Okay, 50 by 3, which is approximately 16.66. Or we'll leave it as 50 by 3 for now. No
So
problem.
left it as 50 by 3.
Okay, leave it like 50 by 3.
And then the last one I did 18 into 5 by 18.
Okay,
And I got 5 units. That's 5 meter
so
per
5
second.
meter per second. So first is 10, second is 50 by 3, which if I simplify, we get 16.66, or if we round it off, 16.67 meter per second. So what's the increasing order of speed? Like 1, 2, or 3, which is smallest?
So the third one.
Third one is the smallest, 18 kilometer per hour. Okay, and then the first one, 10 meter per second.
And then the second.
Then the second one. A train takes 3 hours to travel from Agra to Delhi with a uniform speed of 65 kilometers per hour. Find the distance between the two cities.
So do you convert it to meters per second first?
Is that required? Time is given in hours and speed is given in kilometer per hour. Right. So we don't need to make any conversion. We can find the distance in terms of in kilometers.
So distance equals speed by time.
No. Speed is equals to distance by time.
Then so we multiply it.
See, speed is equals to distance by time. Okay, distance with a symbol S I'm using. Okay, please be careful. Okay, this here, now you need to get a habit that you're using S for distance. Okay, don't get confused. It's not speed, it is distance. And V is speed, yeah, velocity. Okay, for speed or velocity, we use symbol V. And for distance and displacement, we use symbol S. Clear?
Yes, sir.
Okay. Therefore, in this question, we need to find speed. So we arrange the form. Sorry, we need to find distance. So we arrange the formulas. Distance is equals to speed multiplied with
Multiplied it with time.
time. Time goes up, right? In the numerator
Yeah.
to the numerator over there. So
Yes.
speed is 65 kilometer. Okay, per hour. Okay, I can write per hour like this instead of
Yes.
writing like this. Multiplied with time in 3 hours. See, always while solving such question, we just multiply the numbers. But see, one thing you should also understand or learn in physics is we can actually even multiply the units. See, R and R gets cancelled and we get the final answer in kilometer.
195 kilometers.
195 kilometers. Because a lot of times I've seen, like, as the question becomes more tricky, students forget to convert the unit sometimes, or they don't realize when to convert, when not to convert. So if you write your physical quantity along with the unit given, and if it's not getting cancelled, then you know, oh no, here we need to convert the unit. If it can get cancelled, then you don't need to convert the units. Am I clear?
Yes, sir.
A car travels, sorry, a car travels first 30 kilometer with a uniform speed of 60 kilometer per hour, and then the next 30 kilometer with a uniform speed of 40 kilometer per hour. Find the total time of journey. What is average speed of journey? This is first 30 kilometer of the journey. Here the distance is, let's say D1 is 30 kilometer. And speed in this section of journey is 60 kilometer per hour. All right. Second part of the journey, distance is again 30 kilometer, and speed here is 40 kilometer per hour. Okay, Parishi?
Yes, sir.
So I have just few, like, what do you call, I need some help from you in solving this question. First part of the question says find total time of the journey, but the journey has two sections, like first 30 and the next 30. So how do I find total time of the journey? Is it okay if I do it one by one, like time one for the first part and time two for the second part and add it?
Yeah, I
Uh,
guess.
that sounds like a good idea.
Yeah.
Okay, can you just tell me how to find time for the first part of the journey?
So, 1 second.
I'm sorry, I'm using wrong symbols here, right? Though that is easy to understand. So distance one, I'll write it as S1, and the speed one, I'll write it as V1. Distance 2, I write it as S2, and speed 2, I write it as V2. Okay, so yeah, how to find time when distance and speed is given?
So you'll do distance divided by speed.
Distance divided by speed. Good. I think that solves my problem. So it's 30 divided by 60. Okay, kilometer divided by kilometer per hour. So R goes up. So time will get in R. Okay, this cancels. This also cancels 2 times. So 1 by 2 hour, half an hour. Is my calculation correct?
Yeah, it's good.
Okay. Can you help me find time T2? Similarly, what do I divide? The distance S2 by speed V2. Okay, tell me the answer. 30 divided 3 by 4 hours. Okay. So we have individually calculated time for the two section of the journey. Therefore, for the first part, total time is
1 by 2 plus 3 by 4.
good.
So that's 5 by 4.
5 by 4. Okay. After taking LCM. So 5 by 4 hours. So we got the total time of the journey. Simple.
Yes, sir.
Okay. Now in the next part of the question, we need to find average speed of the average speed of the car. So average speed V. As I said, average speed is total distance divided by total time. Okay, what is total distance in this journey? What's the total distance traveled by car during the journey, the entire journey?
100, I guess. Or 30.
30 is for the first part. First 30 and the next 30. So how much is total distance? S1 plus S2. We add both of them, right? So that is 60 kilometers. And total time of the journey, 5 over 4. So I think the 4 goes up, right, in division? 5 over 4. I could have written it here, but then later we take the 4 up, right?
Yeah.
So this 5 goes 12 times, and 12 into 4 is 48 kilometer per hour. Is it fine?
Yes, sir.
Yes.
I hope all of you understood. Okay. Vanshika, this time I will want you to try the question. So take your time, read it, understand it. Yes. Average speed is total distance by total time. So somehow you need to figure out the total distance and total time. Okay, so for better understanding, I brought a train. So it goes from station, it reaches B. So it goes from A to B and then returns back from B to A. So it goes from A to B, it's 200 kilometers, and then returns from B to A. That is another 200 kilometers. So for the first part, average speed is, okay, for speed we do total distance divided by total time. All right, so total distance, Vanshika?
400
400
kilometers.
400, and total time is 3 hours plus 2 hours, so 5 hours. Okay, therefore that is equal to
80 kilometers.
80 kilometers per hour. Very good. Okay, and average velocity.
So you need to divide the distance on it.
So this is total. So for velocity, we divide total displacement by total time. That's it. So total displacement by total time. What is total displacement during the complete journey, A to B and B to A?
So 0.
Total displacement is 0. Good. So it is 0 kilometers divided by same 5 hours. Okay, 0 divided by any number is just 0. So this is 0 kilometers per hour. Understood?
Yes.
Okay, all of you understood this. See, these are the type of questions which you are expected to get in your exam. Okay. Yeah.
So the average speed should be 80.
Oh, I missed it. Oh, thank you for pointing out. So it's 80, not 8. Vanshika said 80. I think I forgot to write it.
Yes.
0. Is a car moving on a straight path covers a distance of 1 kilometer due east. In 100 seconds, what is speed of the car and what is velocity of the car? Yeah.
Will speed be 10 meter per second?
Yes. Yeah. The speed is 10 meter per second.
And I think velocity is also that. The speed is and velocity are related.
Yeah, because it's going in a straight line, right? If it was not going in a straight line, then they will have different values. But because the object is going in a straight line, distance and displacement is same. So it's 1 kilometer, which is 1000 meter per second, 1000 meter in 100 seconds. So that is 10 meter per second. Velocity is also 1000 meter divided by 100 seconds. Same. So this is again. Wait. I made a mistake here. I should not have written the direction there. So speed is just 10 meters per second, and velocity is equals to 1000 meter by 100 second, which is again 10 meter per second, but this time it is due east. Okay, so when you're writing speed, you don't put the direction, but when you're mentioning velocity, you put the direction if the direction is given.